All right, folks, we're moving on to the back side of this first guided problems template for section 10.3, and I call this little piece here putting it all together. So what we need to do now is complete the table for all the trig ratios of the common angles. You'll notice that these are only the common angles that fall between 0 and 90 degrees. And I'm going to ask you to reduce all answers to simplest radical form. Hopefully you notice these four columns are slightly narrow because those answers we're directly recalling those from memory. These columns are a little wider. Some of these we might need to do a little work to figure out what our simplified values are there. It's important to remember that the sine of theta is the y coordinate on the unit circle. Cosine of theta is our x coordinate. Tangent of theta is y divided by x. Cosecant of theta, 1 over y, or 1 over sine. Secant is 1 over x, or 1 over cosine. And cotangent is x over y, or cosine over sine. So those are the relationships we're going to use between the x and y values for the points on the unit circle for each of these common angles. Remember, 0 is 0 radians, 30 degrees is pi over 6 radians, 45 degrees is pi over 4 radians, 60 degrees is pi over 3 radians, and 90 degrees is pi over 2. Now I'm only showing you this table for the angles there in the first quadrant. You're going to need to be able to extend this to quadrants 2, 3, and 4 with all the other common angles. I'm going to go ahead and quickly fill out sine and cosine before we talk about the others. Okay, folks, there's all our sine and cosine ratios, which we should know those pretty solid by now. Let's talk about tangent now. So tangent is y divided by x, or sine theta divided by cosine theta. I'm going to write that up here just slightly differently. I'm going to write it as y over 1 times the reciprocal of x. That's how I'm going to show it in this column. That way you'll see how some things cancel out and how some things simplify. Okay, there's your tangent ratios for all the common angles there in quadrant 1, and I have reduced those to simplest radical form. Let's go ahead and look at cosecant now. Cosecant is 1 over sine, or 1 over the y coordinate, and here we go. Okay, folks, those are your cosecant ratios highlighted there, undefined 2, root 2, and 2 root 3 over 3, and 1. Let's go ahead and look at secant now, which is 1 divided by x, or 1 divided by the cosine ratio. There you have your secant ratios, 1, 2 root 3 over 3, root 2, 2, and undefined. Personally, do I think you need to memorize these? No. I'm not going to memorize a table of values like this, but you should be able to construct it if need be. You should be able to go back to the sine and cosine values, which you do need to memorize, and construct all these other values if need be. Okay, let's move on to cotangent. Now, cotangent, we're doing x over y, or cosine over sine. All right, folks, there's your cotangent ratios. We have undefined, root 3, 1, root 3 over 3, and 0. Again, don't need to memorize these, but you do need to be able to construct them on demand if need be. Let's move down here into example 4. Example 4, it says graph each angle on the unit circle, then find the exact value of the following, and those are the ratios that are given. So I'll go ahead and do the first example here, and I'll talk through it, and then I'll probably go through the other ones pretty quickly. So we have the tangent of 3 pi over 4. The first thing I'm going to do is graph the angle 3 pi over 4. So we're going to start with an angle in terminal position here. There's our initial side. Our terminal side will be 3 pi over 4. So we go 1, 2, 3 pi over 4 is right there on the unit circle. I happen to know the x and y coordinates of that point. That's negative root 2 over 2, comma, root 2 over 2. Okay, so now the tangent ratio of that's going to be equal to the sine ratio over the cosine ratio, or y divided by x, which is going to be root 2 over 2 divided by negative root 2 over 2, and that's equal to negative 1. So the tangent of 3 pi over 4 is equal to negative 1. Notice that the values that I've asked you to do in this set of problems, they're not ones that we looked at in our table. These ones are outside of that first quadrant. Okay, let's move on and do the rest of these quickly. Okay, folks, there you have it. There's a series of calculations for trig ratios other than just sine and cosine, and for angles outside of quadrant 1. Hopefully you were able to follow along with what I did. First thing I did was sketched in each angle. Second thing I did was I went ahead and figured out what the x and y coordinates were for each point on the unit circle, and then I used those coordinates to determine what the appropriate trig ratios were. Okay, let's move on here to our last example problem in this video, and that's going to be example 5. Example 5, we're given information below about an angle, and we're asked to find the exact values of the remaining circular functions of theta. This one is, we're going to approach this one different than with a unit circle approach. This time we're going to approach it with a circle that might have a radius different than 1. So let's first look at this example. Sine theta equals 5 over 13. I hope you remember that the sine of theta equals y coordinate over 1 or over r. If it's a unit circle, it's 1, but if it's not a unit circle, we're just going to go ahead and call that r. So let's see how this shows up in a graph of this angle. So we'll start by drawing our initial side in standard position. Our terminal side, well, it's going to be in quadrant 2. It's probably going to look something about like this. Okay, and what I'm going to do is I'm going to label what I know. I know that this length here is 13. And I know that this point right here is going to have a y coordinate of 5, because I know that the sine ratio is 5 over 13. I don't know what the x coordinate is, but perhaps we could use a little Pythagorean theorem here and figure out what that x value is. X is going to equal the square root of 13 squared minus 5 squared. And if you paid attention in geometry, you'll recognize that as one of our Pythagorean triples. So x equals 12. I'm going to go ahead and label that in the picture right now. Actually, we'll keep it here as 12. And we'll draw our 5 in here, and I'll erase my ordered pair here and rewrite it. So the ordered pair will be negative 12, comma 5. You should be able to figure out why I chose to write that x value as negative. It's because it's in quadrant 2, so I have to move to the left. That's a negative horizontal direction. Now, to come up with these other trig ratios, it's just a matter of going through and using the numbers -12, 5, and 13 in the right combination. So let's take a look at cosine theta. Remember, cosine theta is going to be x. Cosine theta is x divided by r. So that's going to be -12 over 13. Tan theta is sine over cosine, or y over x. So that's going to be -5/12. Secant theta is 1 over cosine, or 1 over x. So that's going to be -1/12. Folks, I said -1/12. You know I meant -13/12. So I hope you know I meant that. Okay, yeah. Because that's actually r over x. Secant theta is the reciprocal of cosine. Cosecant is the reciprocal of sine, so that's going to be r over y, 13/5. Last but not least, we have cotangent of theta, which will be x over y, cosine over sine, and that's going to be -12/5. Okay, let's go ahead and look at the next example. I'm going to go ahead and rip through this one pretty quick. I hope you can follow along. Okay, folks, there you have it. That's the rest of this example 5 part B. I've got all of the 6 trig ratios for this angle theta, which is in quadrant 4. Notice with this example, we never defined what theta was. We never came up with a value for theta. All we did was look at the trig ratios for that angle. And that was based on, we were given an initial ratio and we were told what quadrant it was in. That's it. This should get you through pretty much all of WebAssign for section 10.3. The next part of this section 10.3 that I'll do will be trig identities, verifying identities. That will not show up in WebAssign. Best of luck to you, folks.